Hi, this is Andy. This is another video on library creation. In this video we're going to create an ADC. So this will be part 2 of Altium library creation. I don't think I'll be doing any more parts for Altium library creation. I think this would probably be enough. So let's get on with it. Okay, so File, New Library. It's an integrated library, it's file based, so we'll click that. We're gonna save this as ADC. Brilliant. We're going to add the next two parts. So we're going to add a schematic part to it. Back to projects. We're also going to save as ADC.sclib. We're going to add another part to it. PC. Oh no, I don't want another ADC library. Well, it just showed you can. Oh no, you did that. So we'll save that as ADC. I thought I selected another schematic part. Okay, so that's our two libraries. And that's all we need to create a component. Now, an ADC. Well, it starts with a body. So here, where it's got a line, placed line. If you right click, you can draw a rectangle. Start always at the middle of the cross and then draw down. The middle of the cross is the anchor point when placing parts, typically. So, for instance, if you created a rectangle over there, when you placed it, your cursor would be here, but your part would be all over here. So that's not what you want. So aim for the center. And now we need to add some pins. So let's look at the data sheet. Here's the data sheet for an ADC. And here are the pins. Okay, so pin 1. Here at the top is place pin. Click on place pin, press tab. It will open up a properties window for you. Pin 1, BDD. It's a power class pin. Press spacebar to rotate. Press tab to keep the command active. 2 is ground. So now we can say ground. It's still a power pin. So now we can place this down here. Press tab, keeps the thing active. Pin 3 is V in. Now that's an input, so we do need to change the electrical type. It's an input. So we got that there. So I'm just going to move these up now to tidy them up. We don't need massive room for an ADC. That's brilliant. Press place pin again. Press tab. What's our next pin? Pin 4 is S clock. S clock. That is also an input because it's from the master. Put that there. Pin 5 is S data. S data. That's an output to our master. Pin 6 is chip select. Chip select. Now, if you look at pin 6, it's got a bar over the top of it, which is indicating it's an active low signal. Okay, so first of all, we'll change the electrical type to an input because it is an input from the master. Now, to get a bar over the top, if I press a backslash in front of the S, you'll notice a bar appears over the S. So press tab again, go to the next letter along and put a backslash in between the S and a C. And then you'll notice that you get the chip select sign come up. Okay, there are other ways. There's like you can do an active low input and all that sort of stuff. They're not so common. I tend not to use it. I tend to just use the text view version of it. You could have also called this CS_B. Would have also been valid, but this at least looks like the symbol that we want to generate, and it's from the data sheet. So that's everything there. So now we want to go and find this part. So we can go to, I think I've already found it actually, Moser. Prep for this. So I've found the part in Moser, and now I'm going to copy the manufacturer's part name. I'm going to copy that. I'm going to put that in the design item ID. Now the designator for a semiconductor, I always use a U question mark. The question mark will be replaced by a number after annotation. Now for the comment, on the previous video, we put in like 1K0603 blah blah blah. Now an ADC part number is pretty unique, so I tend to just go with the ADC part number, to be honest. The text, the description, well, we get that for free, so we can just put that in there. And this version is a 12-bit ADC, so we can just put that there, and that's it. So that's all this top part done. Now, like I said, we need to add some parameters. First parameter we're going to add is manufacturer, and in this instance it's Texas Instruments. The next parameter we're going to add is a manufacturer's part number. And no, that's not, I previously copied that, so we're going to copy this and we're going to put that there. Okay, the next parameter that I tend to add is life cycle. Now, if you recall back to what I said about active and, you know, not recommended for new designs, if we have a look at this data sheet here, which is this part, all the way down to the bottom, which is where normally TI keeps all their parts, you'll notice that some are labelled as active in the status field, and some are labelled as not recommended for new designs, and that's the reason why I do that. Okay. The last one that is sort of out of the short list is a link, and the link is called datasheet. Okay, and what we're going to do again is, well, this is the TI datasheet link, so we could just copy that bit, or you could copy the link off Moser or wherever you're going to get your datasheet from. Okay, so we're going to place that in there, press enter. Now, as always, control click, make sure it picks up the datasheet, which it did. Okay, so that's really everything you need apart from the edit supplier links field, and we can add one of those. Now this is from your favorite supplier or suppliers. I tend to use Moser, so there you go, and that's also added a datasheet variable there as well. Okay, so we're going to save this. So that's everything really we need from a schematic. Now we're now going to focus on the PCB aspect of it. So here we go. We're going to go to the tools. We're going to go to the IPC compliant footprint wizard. We're going to go with a SOT23 part because that's what it is. It's a 6 lead SOT23. Now all these fields will be correct because I've already gone through it once. So go through and look at the fields E1, D1, A1 and fill them in. Click on the generate step model and go next and go and fill all these in. As I said, I've already done this video once and messed it up, and I'm going through it again. So they're all correct, and then take the recommended values. Go back, I like 0.1 on my, and click finish. There we got a part. So let's have a look. There we go. It's not very good because it hasn't got a polarization mark there. I tend to like them on my 3D images. I also like to have rounded pads, slightly rounded corner pads. It's a bit more up to date. And 25. Oh, there's my pads. I'm going to delete. So if I do Shift S, that's a single layer mode. So on mechanical 13 is my 3D model. So I'm going to delete that. Okay. Now what I've done is I've gone off to 3D Content Central and I've grabbed myself a model. This is the model here, I'm circling it. And I've downloaded that ahead of time. I'm now going to place this 3D model. And I'm going to place it to the side because I think last time it was rotated. Yes, it was 0. So I'm going to click on it, and then that's 3 times. Bring that and put it right over the edge. There you go. Making sure it's correct. Now that's a better model because now I can see a polarization. Okay. Pressing Shift S brings me out of single layer mode, and I get all the pad geometries. Now I'm just going to click Save on that. A few things while we're here. Click on this 3D model and you can embed it, link it, or pull it from a server. I tend to embed mine, and you can choose the file here. Okay, that's just one thing. The other thing I would say is here, I'm going to edit the name. That's not 23-6. Okay. Now I'm going to hit save. Now I've got a SOT 23-6. Now why, you might ask, why have I done that? Because some people might have loads of parts that use a SOT 23-6, and I'm just showing that you can make a generic part number and point to that generic part number. I personally assign a footprint to a part, so if I'm doing anything specific with that footprint to that part, it only affects that part. Whereas if you assign a generic part to a load of different ADCs or references or whatever, or op amps, all use the same sort of SOT 23 package, if you modify that one footprint, you're going to affect all the parts. So you need to be careful what you do versus a generic approach, or a little bit more effort but more flexibility, but a unique part number to unique footprint association. So that's how I would do that, because I have a library, a schematic, and an integrated library that has its own schematic and PCB. My footprints tend to not get mixed up, but if I wanted to, I could rename that part ADCS 7476 or whatever it was, dash SOT 23, and that would be fine. So I'm going to save this. I'm going to now go back to my schematic, because now we still haven't allocated the footprint. So I need to add a footprint. Now I've created it. Choose a library name, hit browse, select your part, and then it'll appear down here in the bottom right. Okay. Now, compile. And in my components over here, there you go, I have a part. Now, just to show you that what this part is, I'm just going to do a new, I'm just going to close this project. I'm just going to do new PCB. Okay. And we'll just drop a couple of these on there. Okay. And if we look at 3 now, there's your ADC. That's your 3D view. So yeah, it's a nice part. Looks a nice model. Pretty good. Look pretty good in a 3D step model, that. So there you go. that's how easy it was to generate an ADC. I hope, again, it was informative. This will be probably the last one I do on Altium library creation. I don't think there's any need to do any more. It's just a matter of playing with the tool. So great. Again, as usual, thumbs up, ring the bell. It's a new channel, so I'm trying to generate a bit of interest. Okay. All right. Cheers.